Here we have the composition of a trig function and an inverse trig function. Before I start, I want to remind you that this notation cosine seemingly raised to the negative 1 actually is just the name of the function. Nothing's actually being raised to the negative 1 here, that this is just the notation for the arc cosine or the inverse cosine. So an alternative notation would be the arc cosine or inverse cosine of the sine of pi over 3. So this problem really has two parts. Whenever you have a composition of functions, you can do work on the inside first and then take care of the second part next. So let me start by doing the sine of pi over 3. If you're not used to working in radians, you could convert this to degrees, just remembering that pi radians is equivalent to 180 degrees. So that would be exactly a 60-degree angle. So let me draw a 60-degree angle. We'd be in the first quadrant. So this is 60 degrees, or maybe I can fit it in there, pi over 3 radians. So if you remember how this goes, if this is a 60-degree angle and this is a 90, that makes this 30. And since we're in the first quadrant, both my x and my y would be positive, and the hypotenuse is always positive. And we would label the side opposite the 30-degree angle 1, the hypotenuse 2, and the side opposite the 60-degree angle would be the square root of 3. So if I am to evaluate the sine of pi over 3, here's the angle pi over 3, and the sine of pi over 3, if you remember what the sine is, it would be the ratio of sides opposite over hypotenuse. So the opposite side of the 60-degree angle there is square root of 3, and I need to divide that by the hypotenuse, which we labeled, having a little bit trouble with my mimeopad. The opposite is the square root of 3, and my hypotenuse would be 2. So I've evaluated the inner part of this problem here, and it came out to be the square root of 3 over 2, so I can replace the sine of pi over 3 here with square root of 3 over 2. When two things are equal in math, one can be substituted for the other. So my problem now becomes find the arc cosine of the square root of 3 over 2. So on this part of the screen, let me evaluate that. Let me evaluate the arc cosine of square root of 3 over 2. So if you remember how the arc cosine works, or any inverse trig function, the input is the ratio of sides and the output is an angle, which is the exact opposite of this over here, where the input was the angle and the output was the ratio of sides. So what this is this is the angle whose adjacent over hypotenuse, whose cosine would be square root of 3 over 2. Evaluating this would be the exact equivalent of me telling you to solve this equation. Give me the angle, right? The input into a trig function is an angle. Give me the angle whose cosine comes out to be the square root of 3 over 2. So this is just the inverse situation of this, where the input is the ratio of sides, the output of the inverse trig function is an angle. Since this and this these are inverse functions, the input and the output meaning get switched, meaning this time instead of the output being the angle, it's the input that's the angle, and here where the ratio of sides was the input, it appears as an output right here. So these two statements are equivalent. I need to find the angle whose cosine comes out to be square root of 3 over 2. So if you remember right, the arc cosine of square root of 3 over 2 has infinitely many answers, but we all agree that whenever you evaluate the arc cosine, you're going to get either answers in quadrant 1 or in quadrant 2. And if you remember right, cosine is only positive in quadrants 1 and, I screwed up there. Cosine, if we want it to come out positive, cosine is only positive in quadrant 1 and quadrant 4. I know that through the acronym that I've done in earlier videos, all students take calculus. There's other ways of knowing it, but so it turns out, if you remember that all students take calculus, that the cosine is, all the trig functions are positive in quadrant 1. Only the sine function's positive in quadrant 2, so that means cosine would be negative, so it can't be quadrant 2. Tangent is positive in quadrant 3, meaning the sine and cosine are negative, and we don't want the cosine to be negative, so that scratches that one. So cosine is positive in quadrant 4, hence the letter C here, and in quadrant 1. But it turns out that the range of the arc cosine, when you evaluate the arc cosine, you always get answers in quadrant 1 or quadrant 2. You never get answers in quadrant 3 or 4. So that narrows it down to just quadrant 1. If you were to do the arc cosin on your calculator or whenever you're asked to evaluate the arc cosin, by definition the output is restricted to 0 to 180 degrees. So at any rate, we're in quadrant 1, and I know that the cosin function involves taking the adjacent side divided by the hypotenuse. So I need to label the adjacent side of my reference triangle here square root of 3, and I need to label the hypotenuse 2. So again, these being positive, I'm in quadrant 1, everything is lining up correctly. So the correct way to label this side via the Pythagorean theorem or just memorizing the special triangles, this is a 1. So the side opposite, the angle opposite the side whose label is 1 would be 30 degrees, and the side opposite the angle opposite the side labeled square root of 3 would be 60 degrees. So there's my answer right there. The angle whose cosin comes out to be the square root of 3 over 2 would be this angle right here, which is 30 degrees. So x is equal to 30 degrees. The question, however, was in radians, so if you had to convert, 30 degrees would be pi. Remember, pi is 180 degrees. So how do I get from 180 degrees to 30 degrees? Well, I divide by 6. 180 degrees divided by 6 would be 30. So my final answer here is pi over 6, and the question necessitated that I give my answer as an exact value. Now, probably this wouldn't work so well if you were trying to cheat and use a calculator, because you're not going to recognize what the calculator gives an answer, but you certainly can use the calculator as a check. So let me bring up my emulator here and go to the home screen and type in the arc cosin or inverse cosin, that's this second cosin, that's the inverse cosin, of the sine of pi over 3. So you get pi by doing second caret, divide by 3, and I guess I've got 2 left parentheses to close off, so I'm going to give 2 right parentheses. And like I said before, this wouldn't work so well if you were trying to cheat, because you probably would not recognize that 0.5235987 has anything to do with pi over 6. But since you know the answer is pi over 6, or at least you think that that's the answer, you could now type in pi divided by 6, your proposed answer, and check your answer just by comparing. So indeed, the calculator is telling me that the answer to the question is this. My answer was pi over 6, which matches, so this would be a quick check. So hopefully this helped you understand the problem.